Dear friends, today we are discuss about the field effect transistors. Now, field effect transistors is a construction is the same as the transistors, but there are some difference that we see. What is the difference mean? It's also called as a unipolar transistor. Now, unipolar, why they are called as a unipolar? Because there were electrons or holes, either or their charge carrier is involves single carriers. So single carriers are as in operations, that's why is called the unipolar. Now we see the construction. There are three terminal: drain, source and gate. Now drain, source and gate, in between there are channel. It's called as either they are p type or n type. Now these are the symbols or constructions like that. Now here we can see that if we are using the semiconductor n-type material to n-type material between this p, it means that p is a sandwich in between these two. It's called as p-type. Same way here, when n-type material is a sandwich between these two p-type semiconductor material, so it's become n-channel. Now charge carrier is flow from drain to source, and this controlled by the voltage between this gate to source. Now we can see the types of FET. Majorly types of FETs are there two types. One is the junction field effect transistors and another one is the metal oxide semiconductor FET. So further they are departed is the depletion mode, here depletion mode as well as enhancement mode. Now in depletion mode, same way, if the channel is n type, so n channel JFET. If depletion channel is the p channel, then it's called p channel JFET. Same way here, there are two category: depletion mode and enhancement mode. Same way, n channel, p channel, n channel and p channel. This will be discussed in the next session. Here we are discuss about the JFET. Now JFET is the depletion mode, is n channel and p channel. It means p channel JFET and n channel JFET. Now here is the symbols: gate, drain and source. Now arrow is the inward, inside of the from the gate, and this is outside. So n channel is the inside and p channel is the outside. Now how is the working of JFET? Now to understand the JFET, there are two cases. First case is VGS, it means the voltage between gate and source is 0 volt, and VDS is greater than 0, it means drain to source, this voltage is greater than 0. And second case is VGS is less than 0, it means negative, and VDS is less than VDS of case 1. So we have discussed here the first case. So these are the constructions: n channel, p type material, p type material. So p type material, n type materials together make a junction, here junction and here junctions. So this creates a depletion layer here and the depletion layer here. Now the voltage VD is applied between drain and source. Source is grounded, it means 0 volt potentials. Now this positivity is increased here. That's why what happened at that time, the electrons are flow from source to drain this way. So this current is called as natural current, like that. Natural currents, electrons flow from source to drain, and conventional currents, drain current, it means drain to source, it means like this way, drain to source. So here these are the construction, and how it works we can see. Now when we increase the value of VDS, now if we increase the value of VDS, so what happened, the voltage here drain to source is the portion of channel. Now portion of channel is behave like a resistive drops. So here the voltage is more than compared to source, so more potential drop is here. So potential's value is higher at the upper side respect to bottom. That's why here the depletion layer is increased more compared to bottom side, and these two are together. As the VDS is increased, depletion layer is increased, and depletion layer is increased in such a that they are touched together. Here it's called VP. So here is the depletion layer is increased, more voltage is the upper side, so n channel passage will be blocked. So ID is increased according to Ohm's law. ID is increased according to Ohm's law. So VGS is equal to 0, and value of VD is for which two depletion region touch is called the pinch off voltage. So it's called as a pinch off voltage. So VDS is equal to VP, the flow ID is stop and become constant. So here is the graph. Now value of the VDS, and this is the value of ID. At the time of VGS is 0. At starting this behave like a Ohm's law, and then after when the value is reached, voltage is a VP, then it becomes constants, and this. So this graph cut here given a 4 region. One is this region is called Ohm region, this is cutoff region, and above this is saturation region, and beyond that it's called breakdown region. So VDS greater than VP, then saturation conditions, and flow of ID stop and constant. Now if VG is negative, here VG is negative, as here we say in case 2, the VG is negative and VDS dash is less than VDS, it means the saturated value of the voltage between drain and source, which will be less with compared to VDS in case first. At the time what happened? The gate, here is the gate at the p-type material is a lower potential with respect to this channel. So here both side is a reverse bias condition, and this reverse bias condition will create more depletion layer, and that's why this same in a case 2 behave and touch here together and block flow of current. So this way, same way, these are when the VGS value is to be increase as a -1, -2, -3, they are early saturated and breakdown, early saturated and constant, early saturated and constant. So this way we can understood the FET in both the case. So how we can understood very easy way. So here is the we understood, suppose these are the, here is the tap which will be control the flow of water. So these are the gate which control the flow of water. So is equivalent to ID, it means the drain current. So drain to source, when the water is flow, and these are the pressures, or this will control the flow of ID. So same way these are implement here in the drain to source current flow, but here gate is applied and depletion layer is increased, and control the flow of ID. So these are the simple example to understood. Same way we can also understood, suppose in a pipe the flow of water, and now here we are given a pressure in the both side. So this will be compressed, and one stage it will be flow the water. So same way we can understood the FET. Okay, thank you very much.